Pleasure to have Dr. Alexis Vogt here today from Monroe Community College. I have this long introduction, but she said she would be very comfortable to introduce herself, so I will let her do that, but hopefully you'll have some great questions and learn a lot from her presentation. So thank you so much for coming.
Thank you, Karen. I appreciate it very much. Thanks everybody for coming. In an afternoon where the sun is actually shining outside, I realize you have other options and things you could be doing with this hour, so I appreciate having you all here. As Karen said, my name is Alexis Vogt. I am professor and chair of the Optical Systems Technology program at Monroe Community College. And I just need to get my slides to advance. There we go. My career began at the University of Rochester, where I studied optics for my undergrad degree as well as my PhD. And then from there went to work at Bausch & Lomb designing contact lenses for cataract surgery. And then I moved from Bausch & Lomb to Mel's Griot, now part of IS. And it was there that I became acutely aware of the need for optics technicians in Rochester. And so that was my motivation to leave the optics industry and go back into academia. So now, in addition to serving as the tenured professor of optics and endowed chair of the program at Monroe Community College, I also serve in a capacity as the executive director of workforce and higher education at AmeriCom, which is a DoD-funded organization, and I'll speak into more details about that too. And then I do some consultation work as well with individual companies looking for ways in which they can find their future workforce through an LLC that I created called Focus Path. So what excites me about this industry are all of the possibilities and all of the things that we do. I should perhaps begin by, when I say optics, I'm also talking about imaging science. I'm also talking about photonics. I'm talking about a common denominator to, I would guess, every single one of us here in this room, working with light. So lasers, lenses, fiber optics, remote sensing, imaging, all of these technologies and more, I would put as part of this entire industry we're a part of. I'll share a bit about how I fund the program that I lead. Much of it comes from DoD funding. When we think about some of the terrible things happening in our world right now, as of this weekend, for example, our industry and our field really is responsible for safety, for preserving safety. And so I've included some of the examples here on this slide. What we need are more of the people who make all of these products, and more we call them technicians. So where someone with a bachelor's, master's, or PhD would customarily sit behind a computer and design something. They design it, come up with a great idea, innovate it, translate it over to the technician who is then going to use their hands to make it. So what we need for all of these products and more are more of the people to make them. In fact, there's a tremendous need. We say for one engineer, and by the way, we know we need a lot of engineers too. For one engineer, we need 10 technicians. If we look at just the Western New York region, we have 93% of job openings for technicians going unfilled. And in our region right here, we have over 150 optics companies. So a tremendous supply of companies, but not a tremendous supply of technicians who are needed to keep these companies going. So a bit more about how I specifically became aware of this need for technicians. When I was working at Mel's Griot, we started each day with a standing only meeting, 5 minutes or less, just designed to talk about what new orders had come in the last 24 hours and what had to ship that next day. And so we would start these, and with a brand new employee who would have these meetings, and someone would say, the #1 customer, this big company out in California, they're paying double, this has to go today. And someone else would very sheepishly say, Dennis is there. And you could feel the whole mood in the room change dramatically. And we would move on to another project. Well, Dennis will get to that after Dennis does this, and Dennis does, and I'm thinking, where is Dennis? Dennis is never at this meeting. Turned out Dennis was too busy to even be in the standing meeting that only lasted 5 minutes. And so then I canvassed all the fancy C-suite offices with the doors, the windows, nobody named Dennis. And I learned Dennis has a 2-year degree from Monroe Community College. And there was no doubt among anyone in that company that at the time had about 85 people, Dennis was the most important person there. Dennis touched every single thing that went out the door. So then I said, this is not a good business model here. Don't have an MBA, but I'm pretty sure this model is not very successful nor sustainable. And so the suggestion I posed was, hey, let's just go find another dentist. Obviously, that's what we need here to solve this problem. Well, then they said, well, nice try, Alexis, there aren't any. I said, what do you? This is the optics and imaging capital of North America. What do you mean there's no dentist? And they said, well, there's this optics program down the road at Monroe Community College. I said, there is. I've been in Rochester for a long time. I didn't have enough case. They said, but there aren't any students in it. I started asking my colleagues in the area who work at these over 150 optics companies to ask them, do you also have this problem? And they said, yes, that is our #1 problem. We can't find technicians. We can find people off the street and we train them in our in-house because there aren't enough available. Here's a representation of many of these companies here, all facing the same problem. By the way, this is not a geographically sound map, so Albany is not due north, or excuse me, due south of Syracuse. But the point here is there are a lot of optics companies in our region, and they all were reporting the same problem. In addition to the current problem, the projection is for all of these companies to grow. Well, how do you grow? You need to have more workers. You need to have more workforce. You need to have more technicians. This isn't, by the way, I've since learned, a problem isolated to Rochester, nor even to the United States. 85% of German optics companies are reporting that their inability to find enough technicians is stifling innovation. Innovation, what? I thought you said the technician does the day-to-day activity. Yes, but you know what happens if a technician isn't there? The engineer has to do the work of the technician, because if the work of the technician doesn't happen, the product doesn't go out the door. So the people who are brought in to spend time innovating and creating the next greatest design, they have to actually package up the optic, put it in the shipping label and get that work done. Thereby, you're not innovating. So this is a problem that we are seeing transcended around the entire world. Only after exploring this a little bit did I learn more about the Monroe Community College Optics program. Only college in the entire world awarding associate degrees in optical systems technology. Only college in the world. I mean, when I learned this, I was like, you must be wrong. Only one. But there's a huge need, right? This is a graph just showing locations of optics companies, and they're not even all represented here, but these are all companies that need technicians. And they include companies that come here to try to hire all of you and all of your students. You know their names: Apple, Meta, Microsoft, Amazon. They've all come through to tour our labs at Monroe College because they need our technicians to support the workforce. Okay, so why is this such a big deal, and why is it growing so much? At this point, I feel like I'm preaching to the choir because we're all part of this industry. But one of the things that excites me so much is to think about the possibility and the future within this industry. So why does all of this work that we collectively are doing matter? We know that nothing in the world travels faster than light. But what that means is that we can take our devices and we can make them faster, we can make them smaller, and we can make them more energy efficient. That's the direction in which we're moving toward, which is why this field we're all a part of is the field truly of the future, because nothing travels faster than light. And I'd like to give some analogies about how light has transformed the ways in which we live. There are a few of you in the room who will be able to play along with the story. Back in the day, those of you who are in school right now will have no idea what I'm talking about. There was this thing that came out called a car phone. Is anybody with me? Car phone? Thank you, Karen. It's about this big, and it sat in your car between the driver in the passenger. And you know what you could do? You could use it to call someone while you were in a car. You youngsters don't seem impressed. It was very exciting at the time. You had to know someone who's really wealthy who had one of these. I had one of these girlfriends in high school. And you called somebody. Then we progressed to these things called cell phones. Saved by the Bell. Anybody? Zach Morris? Anyone know her? Karen again, thank you. Oh, you do. Right? So Zach Morris on Saved by the Bell had a cell phone. Remember, that's the first time I ever saw one. It was on TV. And it was the size of a shoebox with a big antenna. And you could call someone. And look at where we are now. I mean, we call these phones, but like, when was the last time you actually called someone on it? Well, we do everything else with it, right? We do our banking. This is how we connect with people. This is how we turn in assignments. This is how we live our lives. Go back all the way to the car phone. Faster, smaller, more energy efficient. Maybe that hasn't sold you yet. But what about the possibilities of changing the way in which we charge these? Do you charge this at night next to your bed and it also serves as your alarm clock in the morning? I see some head nods, right? There are people right here in Rochester working on ways we will only charge these once a month. I mean, right? The little, what? What'd she just say? That's right. Imagine how your life changes then. Anybody else also have their phone charger in their backpack because their phone is likely going to die at some point this afternoon, right? So you say, okay, today, oh, we got March 4th. So if I charge this tonight, I'm good until April Fool's Day. That's the advancement that's coming out of much of the research that's happening here, but specifically in Rochester. Okay, so let me tell you briefly about this optics program at Monroe Community College. So we have courses that are built to help people advance in their career. Whether they want to come and take 3 classes and go get a micro-credential and work, we've got that program available. We have a 1-year certificate program. We have a 2-year associate's degree program, more time, more classes, higher starting pay, and of course, 2+2 transfer pathways. And I'm so thrilled to have this partnership with all of you at RIT, but our students can start for 2 years with us at Monroe Community College and then go either here to RIT in your imaging science program to the University of Rochester's Institute of Optics, or for those interested in warmer weather, the University of Arizona's College of Optical Sciences. So our goal is to provide programming, provide classes, provide pathways for students to excel within the industry. I don't usually put this many letters and words on a graph, but I thought this would be interesting just to give you an idea of the types of classes that our students in our program are learning. So here are the optics classes that are here. And there you may notice some similarities to courses you've taken here or teach here. Our optical elements and ray optics class, for example. We're teaching all of these classes, some of them very similar concepts to what's taught here on this campus, but the main differentiator is we're not using calculus. So algebra, trig, geometry, as opposed to calculus. And by the way, I should give a shout out to Jim. Jim, thanks for your help, and for all of your help as we try to improve our pathway on our 2+2 students and make that articulation agreement work. It turns out getting 2 academic institutions to talk to one another and making seamless is not as seamless as you might think it is. So Jim, thank you, thank you, thank you. Here's a glimpse of what our lab looks like. By the way, I invite all of you to come tour. If you're interested in seeing our space and what we have, I'd be more than happy to give you a tour. We have currently over 6,300 square feet of lab space with $10 million in advanced manufacturing equipment. So in our program, we will teach students, among other things, how to take a chunk of glass, very precisely grind it and polish it and turn it into a lens. A lens that can only be verified it was made properly by using a laser and other metrology techniques, for example. So we're teaching students, here's a print that your customer is going to give you. This is what you need to make. And this is how you verify that you made it properly, because if you can't measure it, you can't manufacture it. We are constantly expanding. A lot of the funding that I've brought in at the federal level has gone toward equipment. You all know this well. It turns out that equipment is not cheap when you're in this industry. And so we are constantly adding new equipment in here. Most recently, we have a coating chamber spectrophotometer, our coating chamber was actually just fully installed and ready to launch last week. And SpaceX has also reached out to us and has donated the diamond turning lathe that you see on the bottom right. I don't think ever in my wildest dreams I would have had said that sentence that I just said. Like SpaceX knows about Monroe Community College, had a diamond turning lathe and said, here you go, would you like it? We'll actually pay for shipping and everything else included. That simply speaks to the need. SpaceX needs more optics technicians. So here's a bit that shows the progression of from when I started in 2015 and there were 5 students to where we are today with 153 students, always continuing to grow. You all are likely not here to hear a marketing talk about MCC. But that said, if you know of anyone who might be interested in a career path, I have always welcomed the opportunity to give tours to people. No one has to agree to enroll, but one of the biggest challenges is people don't know this exists. I'm sure some of you have gotten together with people who have no understanding of what it is that you're doing. Any of you students go home for like Christmas break and explain to your family members what you're doing and they just really lost it. Sounds great. Sounds great. I would argue that manufacturing in general has a poor identity, and people think like dirty, messy. That is not what's happening in the optics industry. But in our own industry, we have no identity. Every single person on this campus has a phone. But I don't believe that every single person on this campus realizes they have people within this building to thank for the technology that has gone into developing those phones. If you know any of these people looking for career changes or looking for new opportunities, artists, musicians, gamers, chefs, mechanics, athletes, they make excellent optics technicians. The hand-eye coordination, the kinesthetic ability that's developed through even gaming. My son is always like, Mom, that in turn makes you an excellent optics technician. We're also trying to figure out how we train more people. The Monroe Community College program alone cannot train the entire nation's optics technicians. It just doesn't unfortunately work that well. But we have adopted the apprenticeship model. You likely have some level of familiarity with an apprenticeship. It's a combination of on-the-job training and what we call related instruction, the classroom time. If you think about plumbers, welders, electricians, they have apprenticeship programs, they have trade schools. For our entire industry, we had the Monroe Community College optics program and had 5 students in it. So we partnered with Optimax, local employer here in town. We now have over 500 people. We partnered with Optimax to create the nation's first optics apprenticeship. And then I hired somebody on my team to help roll this out around the country. So we've had 55 apprentices, 14 companies in 8 different states. The way we run this model is those students who are remotely located, apprentices in Arkansas, for example, or in Maryland, they join our classes over Zoom, and then they travel to Rochester for their hands-on component of the class at the end of each semester. So they'll come in January, and then they'll come back in June to condense down the time frame in which they're learning. So they still get all of that hands-on training, just in a condensed time frame. And here you see a picture of some of our apprentices who were here in January. Our high school dual enrollment pathway, we call it, has been one way in which we've been able to grow our enrollment. And I know some of you in the room have taken dual enrollment classes before. For our program, I give the high school teachers my introduction to optics content. The teacher teaches it in their own classroom to their students. Those students then receive MCC credit. I actually think even more important is that they've learned about our industry. By the way, all of those students know about RIT and imaging science because I build it into my optics class that I'm teaching. So then these students in our region are familiar, they at least heard of RIT, the imaging science program, MCC, etc. There are 23 high schools in the area that have taught my introduction to optics class in this capacity with over 2,500 students served. Was anybody in this photo with me? Optifab in October when the SPIE conference was held at the convention center. No, I'm still waiting to show this. And someone be like, that's me on the 7th row. we had in that day, this was in conjunction with the University of Rochester and RIT's Industrial Associates Program. Student Day was held at OptiFab. This is a biennial conference built around optical manufacturing. OptiFab, get that connection there, that SPIE hosts in Rochester. And I organized a student day to bring in high school students, MCC students, U of R students, RIT students, to then have an opportunity free of charge to walk around the exhibit hall, meet the companies, understand what this industry is all about as well. You might notice a few, 3 little ones in the front row. Those are my kids. They're not in high school yet, but they were so excited to get out of school for that day. They've never been more excited to learn about optics. One of the things that drives everything that we do in my optics program is the industry. Ultimately, our goal is to best prepare students to work in the optics industry. We can only do that by understanding what does the industry need. So in addition to having a very active optics advisory board, we are constantly working and connecting our students with the industry. We take all of our classes out on tours of optics companies around the area. We take our students to conferences. Bottom left are our students in San Diego at the Optics and Photonics conference as well. We're trying to expose them to all of the different opportunities that are provided to them and made available through this industry. If any of you ever would like to go visit an optics company, be happy to make any introductions. It's really quite remarkable to be a part of this industry because it's extremely engaging, cooperative, supportive. These companies will open up their doors anytime for you to come in and see what they are doing. Outreach is another way. I'd love for us to do more partnering together between what's happening here, what's happening at FCC, what's happening at U of R. This all speaks to the notion I shared about our industry as a whole not having an identity. And I think you all are very gifted, bright people in this room, and you have incredible drive. But I think there are very few people out in our community thinking, I can't wait to go to RIT's imaging science. It's not something, someone doesn't go see an imaging scientist on a regular basis like they do a doctor, right? Or a dentist. So because of that, I think it's difficult for us to recruit students. And this is where this outreach comes into play. And I would also add one fabulous part about this entire industry we're a part of is it is beautiful, it is fun, it is engaging. There's so many great demonstrations that can be done to excite people about our fields. So I'm hopeful that this might be an opportunity for more of us to do together, students and faculty alike. In addition, one of the ways that we've grown our program, yes, we've recruited more students. When I'm at the 23 different high schools in the area, I go visit them all and I ask the students, not too much unlike I did this afternoon, actually, if you all played along to my little experiment this afternoon, to say their name, what year they are, and then share with me a hobby or an interest. And of course, the reason I'm interested in that is that generally within a classroom of high school students, more than 90% of them are either artist, musician, gamer, chef, mechanic, athlete. And then I tell them more about this field that's perfectly suited for them. It turns out if you ask students to raise their hand if they love math or they love STEM, those numbers are significantly less than if you ask if they like the Bills, for example. So that has been a critical way to grow the student enrollment, but not unlike your labs here, you have to have time on equipment in order for students to successfully be part of your program and leave well-rounded. So as we've grown enrollment, we've had to then just offer more sections of class, right? So a larger lecture and then multiple labs that meet throughout the week, which means we've had to grow adjuncts, we've had to grow staff to support them all, et cetera. So I've identified a few pipelines here. One speaks to the outreach part we were just discussing. Taking these beautiful optics, imaging science, lasers, photonics demonstrations, and sharing them out in the community. A couple of years ago, I did this when my youngest was 3 years old, and so I Well, I took them into his 3-year-old classroom because you don't have to understand the physics and science behind it, but you can recognize rainbow and you can get real excited about that, right? So 3-year-olds, and then a month later, I was at a retirement community where the people who were 103 using the exact same demonstrations. Right, so this pipeline of using outreach from 3-year-olds to 103-year-olds can be an effective way to get the word out about this industry. This, actually, let me point your attention to this middle photo here. This is from Western Rochester High School. So there I am with one of my optics demonstrations talking to this high school class, dual enrollment class. The gentleman that you see standing in the background right over here, his name is Mike Powlin. He taught for over 30 years physics at Western Rochester High School. And then about a year and a half ago, he called me up and said, I just want to let you know, I'm retiring. So I'm not going to teach you your dual enrollment program, but we get another teacher who's going to come in and do this. I said, oh, Mike, that's really exciting for you. Tell me, what are you going to do in your retirement? And he said, well, I'm looking for a part-time job. And I said, well, you come work with me. So Mike is now my high school dual enrollment partnerships coordinator. So what he's doing is his dedicated job, part-time, he's retired, remember, his dedicated job is to go out to the high schools to spread the word about our collective industry and get more high schools to sign on so that their students can receive college credit for what we are doing. So this pipeline of having a teacher become my coordinator, he speaks the language of high school stuff far better than I do. So he's been critical to our growth in this pipeline. I also share this photo here on the right-hand side of my former student, graduate program, Jimmy Salone. He works for an optics company in town. Like many of my students, he has a fabulous story. His story started that he went to college, didn't go well the first time around. He dropped out. He's much better at telling this part of the story, but it's something to the effect of like he had a good friend who told him he should go in to be a hairdresser. As you can see from this, doesn't seem a great match. He was really grasping for straws, trying to figure out what it was he wanted to do. He came into our optics program, got his associate's degree, works for Thor Labs Lens Systems. I'll never forget when he sent me a note. He's like, I want to let you know, I just bought a house. Right, like we're providing pathways and opportunities for these students, for their family members. And then we brought it back and said, Jimmy, would you help us as a teaching assistant? He's like, read some papers or come be in the lab with us. So he signed on to be a teaching assistant. And since then, actually right now on campus just down the road, he's teaching for us as an adjunct. So we're trying this homegrown approach. We find the really great students, we bring them in, and then we bring them back as part of the team. I say all of this to say we're always looking for more adjuncts. So if anyone would ever like to try out teaching or even wants to lower the barrier of entry and be a teaching assistant to grade assignments or be in the lab, it's really a wonderful opportunity, and let me know if you might be interested in exploring that a little bit more. Next time you're driving down East Henrietta Road by MCC, you'll notice there's a big construction project that's happening over there on campus. So for the first time in decades, we're building a brand new building on our Brighton campus, and it's called the Sidor Optics Advanced Technology Center, thanks to Jim Sidor on the left and his sons Jonathan and Matthew on the right-hand side. This will be opening up in the fall. This will be space for us to more than double the footprint of our existing labs. We're going to keep what we have, and we're going to get more space. In addition to that, if you're familiar with that MCC building on West Henrietta Road that says Applied Technology Center, it's next to Movies 10, you know where I'm talking about? That is home to precision machining, HVAC, auto. Apparently that building is so decrepit it was going to cost more to fix it than just build a new building. So those programs are also moving over to the Brighton campus. So we will all be co-located in that space, and we're very much awaiting the grand opening of this, which is scheduled to be in the fall time. We've also been really fortunate to have some wonderful supporters of the program here. Likely many of you in this room are familiar with Corning Fairport. The previous person who ran Corning Fairport, then called Tropel, before Corning purchased Tropel, is John Bruning, who is in the center of this photo here. He and his wife Barb gave $1 million to endow the directorship position of the optics program recently. These aren't things that normally happen at community colleges, by the way. Like our MCC foundation is like, what do I do with this? People who want to endow a position. But it really speaks to, and for those of you who are graduate students now, and likely not from Rochester, this is an incredible community to be part of. An absolutely incredible community. Here at RIT, here in Rochester as a whole, there are just really tremendously wonderful, generous people in this community. And no matter where your career takes you, the fact that you have spent some of your time here in Rochester is going to really elevate your career. All right, so let's just talk a little bit about where we're headed and what happens next. One, I want to point out this initiative that came down from New York State Governor Hochul, SUNY Reconnect program. If anyone has heard of this before, it is actually a free college education for adults age 25 to 50. Maybe you shouldn't highlight this. I'm at a four-year institution. Should we keep moving a little bit faster for this part? It's free education, free. So our optics program is free for adults age 25 to 55 to come in because we need people badly in this space. We are also taking, I mentioned at the onset, our 3-course micro-credential. Come take 3 classes with us. You get a micro-credential. And we're dedicating one of our spaces to be a fast-track micro-credential, meaning you come and in 15 weeks' time, you've taken all 3 of our classes and you go work. So our academic institutions do many things really, really wonderfully. We're not always really great at getting students in and out really fast. And in my particular program, industry wants students. So the feedback I get is things are really great, except we need students a lot faster, which is where this fast track micro credential will come into play. So a student would come in, spend 15 weeks, but it's like a job. It's full time, 15 weeks. Then you're immediately learn some critical skills that make you successful in an employer. And I'm going to talk more in just a moment about this stellar initiative on the bottom left. This is a slide that I put together to give some insight into where funding for the program is that I pulled in. The majority of it has come from the DoD. You also see some money here from the county, from the state, from the National Science Foundation, from individual companies as well. Those of us who run research groups or lead programs have many of these sleepless nights here, as I've depicted in the top right. For me, this is because my current grant of $5.2 million expires September 30th. So if anyone has connections to the DoD and any ideas on ways in which I can pull another $5.2 million, let me know. In all seriousness, the need for technicians is a priority for our nation. So I'm actively looking for additional ways to pull in funding streams to keep this program going as it is. I mentioned AmeriCom as one of the roles in which I'm honored to serve. This is the American Center for Optics Manufacturing, funded by the DoD with 2 main arms. One is all around technology development. In Fairport, AmeriCom has a location, has equipment available that you can rent out and you can use to develop the next greatest technology. The other effort is the one in which I'm more intimately involved with, and that's with workforce development. The workforce development piece is to take the MCC optics program that I've been leading and replicate it around the country. So these stars that you see here, Colorado, Montana, here we are in Rochester, Keene, New Hampshire, Sussex County Community College in New Jersey, Orlando, Florida at Valencia College. These are different community colleges that I've helped start optics programs. Similar in scope to mine, but tweaked for the respective region of the country so that those companies in those regions have the technicians that they need. So this is geared towards technicians still, but the idea is to take the model here that I built up in Rochester, replicate it around the country, because simply put, the demand across this nation is far too great that can simply come out of the walls of MCC. The facility that AmeriCom houses in Fairport has equipment, manufacturing that is available for anyone. You could rent time out on this. And you can use this as a way to progress your own research. This model dates back to the original COM, which is an acronym for Center for Optics Manufacturing, which was connected to the University of Rochester's Laboratory for Laser Energetics. A model such like this, it became a way in which people could get together, kind of share their ideas. They tried to see if they could start up some companies. The original COM, from that came QED. From that came Optical. So multiple companies still in operation here in Rochester came out of the original COM. So this is built to be a similar format where you would come in, spend some time on this equipment, and maybe you can start your own company that would come out of this model that's here. And if anyone would like any more information about any of this or how this process works, please just let me know. But it may be useful for some of you in your respective research groups. And now let me talk just a few minutes about Stellar, which is part of the National Science Foundation engine. So our Rochester Finger Lakes region, which we're including an 11 county, 1.2 million people region, is one of 15 finalists for this award from the National Science Foundation. This is a program that's existed for a few years, but this current cohort is down to 15 people, very competitive process. And ours is focused on lasers. I tried really hard not to say laser focused on lasers. Optics pun. Stellar, it's an acronym. Science, Technology, and Engineering for Laser and Laser Applications Research. Advancing laser technologies in the 11 county Rochester Finger Lakes region. This is geared toward workforce development. It's also geared toward developing new technology with really strong ties here to RIT. So RIT has been a part of this since the inception. I've got to thank Gia for being part of this on our team when we had our National Science Foundation visit. She had a critical voice in all of the research and also the workforce development efforts that are happening here in Rochester. So thank you very much. Our program that we've put together has core workforce development components that are really, really critical to where we want to go with this. So part of Stellar is addressing talent shortage. That's the piece that I've been leading, this workforce development effort. And by the way, it's not just workforce development for technicians. We're talking about workforce development that extends from the K through 12 pipeline, technicians, bachelor's, master's, PhD, entrepreneurs. So out of this work of Stellar is to come more entrepreneurs, more companies. In addition to that, research and development, your RIT colleague Stefan Preble is a co-PI on this Stellar grant as well. So there's a very strong emphasis on research and development specific to laser technologies, translating these technologies into businesses and then scaling manufacturing capacity. In terms of the workforce development piece, we're geared toward a 10x return on our investment, 10x goals. That over 10 years, which is the length of this Stellar grant from the NSF, we would have 10x increase in worker training, retention, and job placement. Specific to our 11 county region. Okay, so how is this unique from other initiatives that have come out? One is that this is emphasizing a region. This isn't just for RIT or for NCC or for UR or just the three of us to work together. This is for an entire region that extends out into the rural communities as well. This is really emphasizing lasers because lasers are part of everything throughout our day. I'm certain many of the research projects you are all working on have lasers in there, or lasers were used to manufacture components of what you're using into your lab. So here's an idea of the partners that we have within this initiative. I share all of these details because if, or as she likes to say, when we receive good news from the National Science Foundation on this, there will be more opportunities to collaborate, to work together, to fund additional research projects, etc. So you see a large swath of engagement from school districts in the city of Rochester, out into the rural communities, to various different optics employers, so the industry part of this as well. Organizations like the Rochester Museum and Science Center has to be part of a program like this if we're going to engage others in our community and bring them in and expose them to our industry as well. And of course, all of our academic partners in this region too. So specific to the workforce development component of Stellar, 4 key initiatives that we are working on. One is to build collaborative processes that engage all stakeholders. Don't want duplicating efforts, but we want to find ways to work together. As I spoke to earlier, opportunities to do outreach together. If we're all going to the same school, let's go together. Let's make this even more impactful in all that we're doing. Let's organize summer camps together, for example. Secondly, to unify and expand our educational offerings. So we will be creating a brand new associate's degree specifically in laser. We'll pilot that at Monroe Community College, and then we'll roll that out at Finger Lakes Community College. For example, develop and deploy innovative and immersive curricula. Anybody like VR? That is a technology our industry is responsible for. Yet we don't fully utilize that as a tool for education. So we want to use that, just as one example, as a way in which we can reach rural communities. In fact, in our region, we're fortunate to have back to our Rochester area that Barry Silverstein, who was the head of development for Meta. He was Kodak long time, IMAX here in Rochester, went out to Meta for a number of years and just recently came back, and he's now leading up the University of Rochester Center for Extended Reality. That's a great connection for us to work with him to develop innovative ways in which we can train people. And then continuing what we always do, recruiting and retaining students. So in summary, these are the folks we need. These are the folks who are really keeping our respective industries moving along. We just need more of them to come enter into RIT's imaging science program, to the University of Rochester's optics program, or to Monroe Community College's optical systems technology program. With that, I want to thank you very much for your attention, your engagement, and I should also point out that you've got a ringer in your midst. I should have started with this. Emmett is a graduate of the MCC optics program, so both he and I can answer any questions that you have. How's that done, Emmett? Well, may I, any questions, any thoughts? Oh, I can.
For your enrollment for the 2-year program, I was curious how many of them are in-state and out-of-state. Do you get a lot of out-of-state kids coming in?
Thank you for the great question. The question, I'll repeat it for the Zoom folks, is about enrollment for our 2-year program. If we get a lot of out-of-state or in-state students, the majority of our students are in-state students. The exception to that are the apprentices that we have. So when we have apprentices from outside the area, they count toward our enrollment numbers. In addition to that, we've had people fully complete our associate's degree, but live in Connecticut. And they're not part of the apprenticeship program, but they take our classes remotely, then they come do the hands-on component. So we do in fact have a model in place that even if you're remote, as long as you're willing to come to campus once or twice a year, we can make it all accessible while being remote. I'll also add to that then that our students are really interested in going elsewhere. I don't know why I thought this, but for some reason when I started, I thought, oh, student goes to a community college, wants to stay within the community in which they attend school. That's totally wrong. And I don't even know why I thought that was a thing. Our students are eager to go all over the world. And if I can just quickly share one story, I was at the OptiFab conference that I showed the photo of the over 350 students there. And I finished something I had to run upstairs and send a couple emails. So I sat on the bench next to these 2 gentlemen. I recognized that they were speaking French. I learned it for many years, but I can't speak French anymore. And I shared this bench with them. And then when I got up to leave, I just thanked them. Thanks for letting me sit here, blah, blah, blah. And we started talking. They asked what I did. I said, oh, I lead the optics program from Monroe Community College. And they both immediately pulled out their business cards, handed them to me and said, would any of your students ever move to France? I said they would. And so would their instructor. So they are desperate for optics technicians all over the world. So we're constantly trying to figure out how do we make this program more accessible to people all over the world. The Introduction to Optics class that I mentioned earlier as part of that high school dual enrollment pipeline, I created that as an online class when we were forced to do that in COVID. I have kept it as a class that I teach over Zoom on Tuesdays and Thursdays from 9:30 until 10:45 because I have students from all over the world. So I had a student from the US Naval Base in Bahrain a couple of semesters ago who would jump on the Zoom and join us that way. I will also mention one very unique thing to Monroe Community College is that we have dorms on campus. So we have had students move here from other states to be part of the college, to be part of our program, and then live on campus. Thank you for that question. It takes one gutsy person to ask a very good question, and I really appreciate that. Roger, please.
I got another one. You mentioned one of the buzzwords of the moment, VR.
Yeah.
The other one is AI.
Yes.
What do you see happening with AI in this? And I can think of a variety of possibilities, but I'm curious.
Yeah, that's a really great question, and actually, I'd love to hear your thoughts as well on what you think. But first of all, I always feel very terrible for my MCC colleagues in, like, say, the English department, right? Because I think their jobs just got much harder in terms of what's actually written by a student, what's written by AI. I actually, right now, at this point, see this as a huge increase in productivity. I think, especially when you think about the work of a technician, so much of that is hands-on and it's critical, and I think it's going to remain that way. So I am not at all concerned robots are gonna take over the world and we're not gonna need any technicians. Right? We are nowhere close to reaching that, but I think AI is going to help make us more productive as people. So very simply put, that's the answer that I would give. What would you add to that? If I can put you on the spot, if you don't mind.
I'm a lot older than you, and I remember back when to get an astronomical telescope of high quality, you made it yourself.
Mhm.
And along about, I don't know, 75 to 85, somewhere around there, it changed because the mechanical grinding got so much better. I'm just wondering if the same thing's gonna happen and, to other kinds of manufacturing.
I think we're going to certainly see some, I hope to use the word improvements, but changes in manufacturing. In fact, in our class, the very first semester you come on, we teach students a class, OPT 213, Optical Fabrication and Metrology, which is where, as I described earlier, we give you a chunk of class, we teach you how to hand grind, hand polish. The next semester is the CNC version of that class. So it's computer numeric controlled. So we're teaching you how to make the same lens system, only now computer's doing it, but you still have to understand how to make it in order to make that happen. By the way, that's Optical. That's a company here in Rochester that makes those equipment that came out of the Center for Optics Manufacturing. So I think we'll continue to see advancements in that. That's an interesting comparison between the advanced version with the Optical machines and the conventional method, the hand method. So these big Optical machines, they were in that picture that I showed. Each one of them cost $250,000. So the picture I showed 4 of them. So there's $1 million of equipment right there. I'll spare you all of the details, but it turns out when you're bringing in a piece of equipment that needs air hookup and water hookups and ceilings lifted, that doesn't work really well at community college. So that's all speaking it up itself. But these are big pieces of equipment. They take up a lot of space. They have all of these hookups, and then they can run a single lens at a time. Whereas this conventional method, you've got a single operator who can run dozens of lenses at the exact same time. So the throughput still there. So if you go to these state-of-the-art optics, when you go to Optimax, they're going to have those Optipro big fancy machines, but they are going to have dozens of those old conventional bays because the throughput is just not there yet in those advanced versions. Thank you. Please.
Yeah, I just had a general question about overhead. So, the program's growing, getting buildings, there's a lot of equipment coming in, a lot of it's donated. But your last comment about the machine, I'm thinking about influx of money and keeping it all afloat. So, the bigger you grow, the more responsibility you have, the more overhead, you got a maintenance cost, you're hiring more people, you need more, generate more revenue. Sounds like fortunately a lot of stuff is being donated, so that helps there. But in general, I don't know if this is something you can comment on, is there any worry about, moving forward in 5 years that if funds sort of like dry up to keep the lights on, if you will, you know what I mean, overhead costs? Or are you like, oh, that's never gonna happen, we get more money than we know what to do with, and we're just gonna keep growing? Or like, boy, we better stay steady state because, do you think about that?
Yeah, I really appreciate the question. There's a lot of this. It is not a great model. I mean, I built this more than I was anticipating. I didn't have any idea. Frankly, when I started, I thought I was still needed in Rochester. I didn't realize there was a worldwide shortage of optics technicians. So it's just multiplied over time. I've been fortunate to be very successful in pulling in funding, but I don't know what happens on October 1st of this year. Because my funding from the DoD covers all of my faculty and all of my staff. I'm the only person supported by the college. I can't do this by myself. So it is a huge concern that I have. Now, the college is very supportive of the program. That's why we have this brand new building that's going up, right? So part of me thinks something's going to happen, right? I'll be able to translate some of these faculty lines onto operating dollars, but I don't need some of them. I need all of them. Oh, and by the way, because we have a new building, I need to double them.
Yeah.
The college isn't simply going to, we're a community college. The tuition isn't going to cover the cost of my entire team, for example. It is a very difficult situation. I don't have a great answer. So I spent a lot of time concerned about this. Fortunately, our elected leaders are really supportive of this, so I'm working with them to see if there's additional follow-on funding that I could pull that way. Industry has been very supportive of the program as well, but there is no secret recipe that I've come up with yet. But in all seriousness, if anybody has any suggestions on funding streams, I'm always looking to explore that. One other challenge is a $200,000 grant. You hate to ever turn away money, but not that much right now, right? Those of you who are very versed in pulling in funding know, like, that's going to be more work for me. So I need like multiple millions of dollars. So it's a very big concern that I have, but thanks for picking up on that and highlighting it. I appreciate it.
So can you open your equipment to the local small business?
Can I open up the equipment to the local small business? That's a great question, G. In short answer, yes. We have some people who have done that. We are in many ways kind of inventing the path as we go. That's not something that you would customarily see at a community college where you have a program renting their equipment. But it is something that, yes, we have found ways to do that in the past.
You can team up with America.
Yes, and team up with Americom, that's a great suggestion. In fact, when Americom was building their facility, I was really advocating for that facility to be located somewhere much closer to campus so we can have overflow. And unfortunately, it ended up in Fairport, so it's about half an hour from our labs to the Americom lab. But I love how you're creatively thinking, because that's exactly what I need help doing.
I want to make a comment about this adult re-entering optics.
Yes.
So when I was at elementary school in Arizona, I had met an RIT student that I otherwise wouldn't met. She is a student from cybersecurity, has a 4-year degree. But then she went to MCC to get a 2-year associate degree. With the purpose she wanted to enter graduate school in optics. It's very interesting. She wanted to enter the optics field and doing a reverse way.
Absolutely.
So this is the opposite of 2+2.
Yes,
So
it is. Yes.
that really intrigued me. So I when you say this adult re-education, maybe you could feel this need.
Yeah, that's a great suggestion. Absolutely. Don't do a reverse 2+2. One of the things I've been working with the Institute of Optics, but would be thrilled to expand it to RIT as well, is to in fact have both undergraduates and graduate students in the respective classes taking our classes as technical electives. So the Institute of Optics puts out some of the world's best lens designers, right? Amazing lens designers. Sometimes their design abilities are so good, you hand it off to someone who then realizes, except you can't make that, right? But nobody in that optics program at U of R has taken fabrication classes because they weren't offered, right? I learned that when I got into the industry, and now I'm teaching at MCC, not when I was at U of R. So we're working on a pipeline to have more of their students actually take our classes, which is, like you're saying, a reverse 2+2 in a sense.
So I made a comment at the start of the meeting with the underside program manager. For example, the associate degree you're proposing for
Yes.
user engineering, if you have a 1 week in the summer, potentially we could send our PhD students to your class for 1 week because they have great theoretical knowledge. But 1 week of lab work combined with them enormously. So I think that's a good idea.
I think it's a great idea. Any ways we can partner together to create more opportunities for our students. Again, I just see it. This is such a wonderful institution. And by the way, I'm so grateful for being here. Thank you so much for all of your help, Karen, arranging my afternoon here. But just even spending time with some of your colleagues here, why aren't we doing more work together? Right? Yes, we have our formal 2+2 program, but I agree with you. Let's create more opportunities. Let's spend a week here, a week there, and absolutely build upon the successes that we enjoy. That's a great suggestion, Chair. I appreciate you mentioning that. Yeah, the back, please.
Great talk. Just to add on that, so we talk about imaging change here all the time, and I think this talk was I was very appreciative of how you talked about the missing part, which is of the fabrication part. Talk about lens designs, and I think students don't really see what goes into it. And it's such a critical part of the imaging shape.
I appreciate you saying that. You know, it's so interesting how we frame what it is that we all do. And it's different, right? Whether it's in this audience of people who all understand this really well, or walking outside around campus or down the road and explaining what we do together. But I think there's so many opportunities for us to do more of this work together. We're all talking about light, right? Maybe different wavelengths for different applications, but fundamentally there are a lot of connections between all of us. Thank you. I appreciate your comments very much.
There's a question online.
Oh, please, a question online.
You may have said, but can you do the in-person micro-credentials and or certificate programs outside of normal working hours?
Well, that is a great question. Everybody here, Karen said, can you do the in-person micro-credential outside of working hours? The answer will be yes. We have the micro-credential classes are 3 classes. It's our conventional fabrication class that I mentioned, our advanced fabrication class that I mentioned, and optical systems. The first of the 2 all have both day and night classes. So those can all be done in the evening time as well. The last class, optical systems, we will be moving to create an evening class of that, but right now that's only a day class. Once we have our 15-week plan put in place, we're looking into, in fact, we're working with our advisory board and others in the community to determine, do we want to run that in the daytime or in the nighttime? So for some people, running that to a 3 p.m. to 8 p.m., for example, is a better schedule than full daytime. So the details on what the actual time frame of that fast-track 15-week micro-credential are still being ironed out right now. But the standalone 3 classes, yes, 2 of the 3 can be done. Thank you for that question. We're right at time, and I'm told there are cookies outside, so don't let me stop anyone from cookies and treats. I will be moving out there though, if anyone has any other thoughts or anything else, but Leslie, thank you. Thanks for this wonderful afternoon. Thank all of you so much for being here. It's really been a pleasure to get to know many of you as well. Thank you. And thank you, Zoom folks.